All right, so we're going to share my screen where everybody can see what's going on. And like I said, so this is the content page for this week. Golf scores and grades are just text files that we will be using in the assignments and examples. File examples I will do in class and record on Thursday. The files lab I set up correctly this time. It is an assignment. You should be able to turn it in there. Messed that up last week. Isn't it nice to know that your professors are human and we make mistakes too? You can see me typing, so you all knew that. And then I have a PowerPoint we're going to cover today on files and the new content. So that's ready to go. But if we go to the other we go back to the content page. I have also put in project 3's stuff. So you have a test next week you have to take. Exam 3 is next week. Project 3 starts next week. And that's it. There's no new material covered. There's nothing due next week except for the exam. And there's no Zybook reading next week. There is Zybook reading this week, which I don't think I put on the content page. So there's the thing I missed today. I knew I was missing something. There is Zybook reading for this one, but I'm not going to give you any labs. It's just going to be, you went through and read it. It's just going to be the participation things. That being said, the reason I'm doing that is because y'all won't read it if I don't give you a grade for it. In general, students don't read if they don't get a grade for it. I kind of see that. So the next week, beginning April 17th, is another week of us working on the project. I will go over the first week for sure. We'll go over how to do parts of the project, and we'll actually write some code. So I will videotape those sessions for sure. The second week, depending on where we're at, if we've gotten into the challenge portion where we're doing part 2 and part 3, I'm not going to do as much code for you because I want to see what you guys can do for yourselves. But I will answer some questions. If you're in the online course, you are highly encouraged to send me emails and screenshots of anything that discuss you messed up. I will be happy to respond to them. I also will be happy to set up meetings with any of you virtually or in person to go over any of this in my office. If you don't believe me, ask the 2 or 3 students in here who have actually visited my office. I did whenever some code today, whenever some code yesterday. I don't mind. This is actually the first semester that I have not had students sending me questions about their code. I used last semester I'd get 2 or 3 minimum a week where somebody said, I am stuck. What does this error message mean? And send me a screenshot. I'm not getting that as much this semester. So y'all are either really great coders or you won't ask for help. I have my opinions. All right. That's what I'm here for. Ask me questions. Pick my brain. Send me an email. Now, if you send me an email 2 hours before it's due, I'm probably not going to get back to you in time to make enough difference. But for like the project, if you will send me an email at least a day before it's due, I will do my best to make sure you get a solution or a suggestion for a solution before it's due. I usually am pretty good about responding to emails in 24 hours or less, unless something weird's going on. I actually responded to some emails last week at 1 a.m. because I had insomnia and somebody emailed me, so I responded. They were still up, so they responded back, and we had a little conversation at 1 a.m. Won't guarantee that happens, but there are days that will actually happen. Project 4 is going to start officially on the 24th, but I have already posted the directions. So if you know that, hey, I forgot to turn in project 2, I really need to put some grade in there. When you have time, you can go ahead and start looking at it. It's going to be all about files. So this chapter is going to help. You cannot replace project 3, but you can replace project 1 or project 2 if you get a higher grade on project 4. If you get a lower grade, I'm just going to ignore it. So it can't hurt you to do it. It can only help you. Unless you made 100 on both the projects, and then time management, use your time to your best ability. That being said, remember I dropped 1 of the 4 tests. So if you made an A on all 3 of the exams so far, you can opt out of the final. The final holds no more weight than any other exam, because everything's been comprehensive up to this point anyway. It holds no more weight. That being said, if you were sick and you missed one of the exams, then that one will be dropped and not a problem. Everybody clear on that? All right, great. So let's go look at the PowerPoint for today. And this is a relatively short chapter, so it's not a lot we're going to cover. It's very specific. So last class we talked about collections, we talked about strings, we talked about lists. These are going to come back in because the way we read things in uses strings and lists. We will have to use those indexes, we'll have to use those slicing operations, and we'll have to use that iteration as we're reading these files in. So files are great. They allow us to have persistent storage. Not permanent. We're not going to call it permanent because files fail and you can erase them, but they're persistent. They don't just immediately vanish unless you got really bad luck. So if you save your files, they should be there when you come back. We have several different types of files. Project 3 is going to be working with image files. These examples are going to be working with text files. So we have images, we have application files, and then we have the basic text files. Application files would be like your Word document, PowerPoint, those sort of things. Those have a formatting that are specific to the program that opens them. That's the reason you can't copy and paste from a Word document into a text document and it go cleanly because the formatting is slightly different. That's just one example. We all good so far? Cool. So we are going to be working with text files, and the text files specifically we're going to be working with in this chapter are what we call comma separated values. So you can do this in Excel and other databases. You can download spreadsheet data, and each row becomes one line, and each column of data is separated by a comma. Instead of having a cute little grid thrown around it, it just has commas separating different fields. So each line is a data record. Each piece of data in that record has that symbol, that's a comma in this case. There are other types of files that use different symbols. Some of them use a space or a slash, that sort of thing. They're usually .txt files, which is a text file, or a .csv file, which is comma separated values. File extensions are important. If you haven't been taught that yet, file extensions are what tell the computer what program or what application they need to run it. So a Word document has a .docx now for document file. Notepad's going to do text files, txt. Excel has XLS, Excel something. PowerPoint and PPT. That tells the computer which program to start to use the file. If you get a weird file that you download and it has some extension that you don't understand, I would suggest you not open it because it could be a virus. So, file name in this case is steps.txt, and it's going to store the date the person walked, how many steps, and some other number. And this is my assumption because there's no label to these fields, right? I can tell the first column is dates because it's the standard American date format, right? I know that as long as we're doing American dates, that's July 1st of 2018. If we were in other countries, then we go, that's the 7th day of January, right? So how do we know what each of these fields represents? There has to be a key, and normally, I should have made a slide for this. Like in Excel, you have a row at the top that has the headers in it. So generally in a text file, it either has the first row as all the headers, or you created it so you know what the rows are. If it doesn't have the headers, you can only guess. So in this one, I would say that's the date because it looks like a date format. I'd probably say the second one is how many steps they did that day. I have no idea what the 574 is. Because I don't have any reference for what that number would be. Unless we're doing a total for the year. I don't know. I could just make some random educated guesses. Files have specific path names, and this is very important for the next 2 projects. For you to be able to access the files you need to complete the projects, they have to be located in the right place, or you have to be able to give the computer the path name on how to get there, which is basically the GPS direction for your computer. This is what your GPS would tell you, like, turn right, turn left. Path name is which directory am I going to? What folder am I going to? What drive am I going to? It needs all these pieces of information to get there. The caveat to that is if you put all of your files in the same folder, it looks there first because it makes the most sense. I'm going to look for stuff that's stored with me, and then you don't have to have the dedicated path name. You don't have to go C:\documents/ CS1300 / lab8 / whatever. So in this particular case, C:\classes 1300 homework Wayne Yoder homework 8.py would be the exact path name to get to this homework file on Dr. Yoder's computer. We don't have to have all of that if it's in the same folder. If we put our program that's running it, like if we put our PI file in the same folder as our data file, we don't need all of that information. And I'll give you some examples of that as we go along. If you want to be absolutely 100% positive that you're going to get to the right file, you can put the whole path name in, and you don't have to worry about whether you're in the same folder or not. You just go get the path name. And if you ever wonder where the path name is, when you do your file explorer, and let's say we go to desktop, this up here helps you create the path name. So it's not so great in here. Let's go to documents. So it's got little greater than, less than signs instead of slashes, but this would basically be kind of your path name. You could go, oh, this PC, so that's C : documents slash download slash, that helps you build a path. In other places you can, other non-Microsoft places, it can give you more exact path names. In the dark ages of computing, when I was doing this, we would sometimes have to write these path names out, or especially if we were using a Unix or a DOS-based machine, and we'd have to, actually tell it which directories to change to. So, welcome to GUIs. They're a great thing. GUI. Graphical user interface. Because we don't actually refer to them as that anymore because it's the norm. Everything has a graphical user interface now. Again, when I started this, not everything did. So, that being old thing. So you can use relative path names instead of concrete path names or exact path names. You can do that by putting a dot and a slash in front, and that means that you assume that you're already in the right directory and you just need to go to the right folder. If you need to go back a folder, you can use 2 dots, and then it will look one folder behind where it's at. This is old school DOS kind of notice.
Technical sleep.
Yeah, this is older stuff.
If you really had
to do it, we'd spend a lot more time on it. But you need to be aware that the computer's not just going to randomly look for your thing. If you ever tried to go into your recent documents or your Word documents and you're trying to find a file you just worked on, or you say, oh, I know I did it, but it's not showing up in the list, it's because it got saved in a different folder and then you have to go looking for it. Well, this is the equivalent of the computer going looking for it. I can't tell you how many times that I thought I was saving in one place and the program saved it in the default save location, and then I had to go find the default save location. So we're gonna be reading those files. We're gonna learn how to open a file. There's a function for opening a file. And oddly enough, if you put the file in the same folder, you use open file name, comma, R. R means that we're going to read only. You can actually read write and other options there, but for our purposes, we don't want to change the data, so we're going to read only. R means read only. Most of the time, you want to read only your files unless you are absolutely sure that the changes you're making are right, because if not, it's hard to get back. Yes.
Those comments.
Well, not exactly. The comments are gathered up based on their symbols and put in, and then it writes them out to a file. There's a little more to it than just because they have to find them and gather them and then write them out. It's not. This is overly simplistic file usage. What we're doing the very simple version of it. When you get into other classes, they'll talk more about how to create applications that read and write. And project 3, you are going to create your own pictures and stuff. Yay! Any file that you open, you must close. If you don't, it stays active and it's eating up your processing time and your memory, and it leads you to accidental write errors because you left a file open you didn't mean to. So close is really simple. It's just stepdata.close. So open reads the file into the variable you created, the variable name dot close closes the original file. Will I take off points if you open a file and don't close it? Yes, yes, I will. So always close your files. Will Python let you keep going if you don't close your file? Yes, yes, it will. Will I take off points for that? Yes, yes, I will. I just want to be clear on that. All right, so when you're reading in a comma separated file, it reads it in one line at a time, and it always puts a return character, the /n, at the end of that line. So when you start using the data, you're going to have to take that off. Just be aware, you'll have to clean that up. So the data that it reads in, each row that it reads in is read in as a string. This is why we needed to talk about strings before we did files. So each record or each row is a string. That string will then have to be split at the commas into individual pieces of data, which a good thing you might want to do, and I'm going to teach you to do, is to take that string, split each piece of data into an element of a list. Now each record is a list, and you can access the pieces of data in the list by the index number. So if I needed all of the dates, then I need 0 element from every row. That makes sense?
Little. Nobody else, that makes sense. No.
No, okay, so you have to tell me if it doesn't make sense. So if we have a string, we can't go, I need the number of steps.
Just a string or like?
Yeah. So when this is read in, it's read in straight as a string.
Okay.
We're going to convert that string by using split, and we're going to split at the commas. And when we do that, that creates a list automatically of elements. And now each field has an element number or index number in the list. So that being said, I can now get to specific pieces of data on that row using an index number that I could not do if it was a string, because a string indexes every character.
Transforming it into something.
We're transforming it into something that we can use more effectively and easier in the list.
Okay.
So the list now is going to store dates, steps, and whatever that last one was, time. We'll call it time. I don't know.
As referenceable index.
Which are referenceable indexes by 0, 1, and 2.
Makes sense.
Thank you. Keep asking questions until it makes sense. Because if it didn't make sense to you, it didn't make sense to somebody else back
That
there.
was a little much.
I talk really fast too, so slow me down, make me go back over it. Any other questions? Did that help in the back? Thank you. All right. So if we do that, we can, because now it's a collection, we use the for loop collection, and we can print out data from those lists. We can print out, each line. Because it read in each line as its own record, we can print each thing out. So we can say current line, inset data, print the line, and I can look at it, right? But if I want to split it, I guess I should have waited till the slides came up. But if I take that line and it comes in as this string of AB, oh, what happened? I didn't touch anything, did I? All right. So if we see this, if you see this list of string, so this is how the computer reads it in when you do the open read. Everything comes in. It had one row, and it's like AB 4.2 dog, that was just random information that was read in. Now, we can split it by using myString.split, and the element we're going to split on is comma into values. Values is now a list. So now it's A is first element of the list, B is the second element of the list, 2 is the third element, 4.2 is the next element, dog is an element, right?
Does it, if it were not separated by comma, it has to be commas, right?
Uh-huh.
Can't be anything else.
Well, yeah, it could be something else, but you would put whatever that is right here.
There it is.
So if it's separated by a space, you put a space in. But for what we're doing is going to be commas. And when the list prints, it prints those commas in there, but they don't really exist. This is just for your readability of creating a list. So when I do that, I open the file. I take the current line in step data because it just read it all in. And I'm going to convert each line one at a time into a list. So it's going to take values. It's going to split it, make values into a list, and then I'm going to print the second element of that list. So see, it makes it where you can get two referenceable data. Yes. And then I close it.
So important.
It is important. So if you want to build a list of just the steps in the file. Yes, sir.
I get you to go back to the list.
Absolutely. These slides are all posted and coursed in, so you're welcome to go grab them and download them. You can download them all. Why I try to put them out there, because sometimes you want to go, what'd she say? And go back to it. All right. So let's say on that example I just had that I just want the second column of information, the total steps, right? So we had dates, we had total steps, so we had a number that I didn't know what it was.
Yes.
So if I just wanted the total number of steps, I don't care what date those steps were on, I could create a list that just held those by accessing the other information we just read in. So I'm going to show you the example. So we're going to read in the file one row at a time. We're going to split it into that list where each row is its own list. And then we're going to create a new list that's only going to get the second element, or element 1, index 1 of the data. So we're going to append our third list with element 1 of the data. I think I have a, where did my slide go? I hate PowerPoint and I don't like each other today. So let's go to idle real quick and I'll show you what I'm talking about. Maybe. So let me make this bigger. So if we had this, right? And this tells me to print out the steps every time, right? We could change it to where we're saving those steps instead of printing it. Right? So I could create an empty list up here just called steps. And then instead of printing values 1, I could come in here and go steps dot append values 1. And that should create a list with all of the values in position 1 of every row of that array, of that file. Does that make sense?
You showed the.
I'm gonna, yeah. I gotta make a text file real quick. So. Yeah. The numlock has to be on for that to work. Let me create a file real quick. 7.1. And I'm just making up numbers at this point because I don't remember what was on the slide. No letters. All right, so I saved this on the desktop and I saved my idle on the desktop. Fingers crossed this is gonna work. Well, it won't work because I didn't print anything. So I had two files. It has two records. It grabbed them and it printed them. It grabbed them, put them in a different list and printed them. Does that make sense? So
Hey, so steps dot text is that entire thing, both of those are on there.
So this is steps.txt. It has two records with 3 pieces of data each in them.
If you had the entire year, it would still just iterate through.
It would still just grab each of these. Mhm.
Each row.
Say that again. Current line means that it's just a placeholder in your for loop or your index in your for loop. So this says I'm going to go all the way through step data, which is a long record. But each line is going to temporarily be put into this variable called current line. So it's the current line I'm working with. So current line will change every time the loop iterates. So it's the first time through, it'll be the first line. The last time through, it'll be the last line. So current line changes, but it holds temporarily the line that you are on at that instance in the program. So that's the reason it can jump from one line to the next. It does current line, it splits it up, puts it into values. That takes the element 1 of values and puts it into steps, and then it prints steps. Now, values changes every time through this loop also because it was a variable only set up inside the loop. That's the reason I had to do steps as a variable before the loop, because otherwise it would reset every time through the loop. So this goes back to scope of variables, which I think we need to touch on again. So if a variable like values is first used or first referenced inside of a loop, it only exists in the loop. Once the loop stops running, you can't get back to values. Steps up here was created in the program outside of the loop, so therefore it continues throughout the entire program. If steps is then used in a loop, it just keeps adding to it every time it goes through the loop. But values doesn't because it's created in the loop.
Each time.
So it's recreated every time the loop runs.
Based on whatever the value is.
Right.
Okay.
Front row's nodding with me. Back row's got me. Everybody in the middle just ignores me.
Oh,
That's okay. All right, so does this make sense? Did you see how the files are saved in the same place? So they're both saved on my desktop. I can just use the file name. If I had put file in a different place, like if I had put the steps in documents, and I would have had to put document/steps. So it would go looking for that. That make sense? So that's why when you start reading my directions for project 3, and it very clearly says, put all the files in the same folder, that's why. Because I'm gonna give you a folder of pictures, and you're gonna be able to extract them onto your computer where you can play with them, and then you'll know that your pictures look like my pictures. You don't have to use my pictures, you can use your own, I don't care. But if you want to, a lot of students like to make sure that the example I use and what they coded were the same. So when I do that, you're going to extract this, and the extraction program is going to put them into a folder called pictures. And your code is going to be in just whatever document folder or Pi folder that you created. So you have to put those pictures into the same folder, or you have to remember to put picture/picture name to find it. But I'll help you do that too. I will help you set up. The first thing we will do next week is I will help you set up your file structure to make sure it works. Because that seems to be a stumbling block for a lot of students, because you've come from a Windows or a Mac generation where you've had visual aids to help you do file organization.
I'll say this, the turtle graphic thing, for some reason that lab, we use this, I just felt arbitrary, at times, I have to look at this correctly as far as I can. This has pictures are good.
And that's why I try to do my projects, the big projects that I can with something visual. That's why I use turtles, because visual learners like visual representations of what's going on. That's the reason we're going to use pictures to test your understanding of loops, array, list arrays, lists, because the pixels are going to be stored that way. You're going to learn how to use indexes. You're going to use conditional statements. You're going to use nested loops to navigate your way through a grid of pixels. And it sounds overwhelming, but it is a comprehensive view of everything that you should have learned throughout the semester. And if you didn't, we'll have time to reiterate it before you leave. Right? All right, I'm done for the day. That's all I really had on files. We will do examples of reading in files and manipulating the data, and I'll write idle code for that on Thursday, and I will videotape all of it so you can go back and look at all of the files. Any questions for me before I turn you loose? Anybody have any questions about what's due tonight? Stick around and I will help you with that before you go. All right.